So, hey, folks, welcome back to Quarkus Insights after last week's cancellation. So this week we have Clement to talk about the new awesome Redis API. We had an API before, but this one way better. Clement is going to tell us all about it. Uh, Holly and I will be here to ask questions. Holly will be asking all the smart ones. I'll be asking all the stupid ones. But before we get into that, I think we should see what kind of news we have. We definitely have Quarkus 2.13.2 final released. What was it, Thursday or Friday or something like that? And 2.13 will probably have like plenty of minor fixes, like probably going along like every week or so.
And another thing for our viewers, last week was DevOps Belgium
Yeah,
with
I was going to ask you.
plenty
I was
of
going to ask you both
talks
about it.
on,
Yeah.
a good Quarkus coverage, plenty of talks about Quarkus. I did a deep dive. Holly did a contract testing talk. And the good news is that all the talks, including deep dive, are already available on YouTube. So
Yeah, I saw it. It's awesome. 2 days
yes,
after the talk. Yeah, that's amazing.
They're so fast.
yeah, it's very, very fast. So if you look for what's happening cool around Quarkus, look at the DevOps and you will find plenty of content. So Holy, there is um, one about Optaplanner, I think. So there is a few Quarkus talks that are really, really good.
Yeah, and there's some Quarkus talks that we weren't especially involved in either.
Yep.
So AWS had a lab or a deep dive about AWS.
So it was a lab about Lambda with Quarkus. It was full, so I was unfortunately I wasn't able to participate. Microsoft also did a lab showcasing Quarkus on Azure. I didn't participate. Dimitris did, so he was quite happy. So yeah, it looks good, and I think it's also available online. So check it out.
Yeah,
Awesome.
I feel less bad that I didn't go to the AWS one because I really wanted to, but I had to make my demo work. But it sounds like even if I tried, I couldn't have got in anyway. So.
Yeah. I was 3 minutes late and it was full. I said, yeah, okay.
Lesson
So I
learned.
posted a link to the YouTube channel where there's a huge amount of content. Well, I couldn't really find all of your folks' talk, so I'm gonna leave it to our viewers to go through and find them on their own. So next weekend you'll have a lot of catching up to do, everybody.
Yep.
Awesome. Do we have anything else, or should we dive headfirst into Redis?
I think we're good.
Awesome.
I don't have anything else.
Awesome. So let us know what's going on. Why do we have a new API?
That's a good question. So for people not knowing what Redis is a key value data store. It has all the cool things, clustered, persistent, and so on. And if you never use Redis before, and we will see that in this insight, it's designed with simplicity in mind, and that's what is really, really cool. Is that it's really simple. It's really easy to understand what's going on, and that is the secret source of their popularity. If you go to the Redis website, you will see that they say that they are used by millions of developers. I don't know how they counted them, but yeah, at least I'm one of them. So yeah, that's one. But the whole idea behind Redis is, again, it's a key value data store. So you are going to store values identified by key. That's relatively simple. To manipulate those values and keys, you will use a command reply protocol. So it's you send a command, you get a response. You send a command, you get a response. Very simple. Most of the protocol is like that. There is a few extensions, especially for PubSub, but everything else is very, very simple like this. So basically, if something doesn't work, look at the command you are emitting, look at the response. Oh, yeah, okay, that's it. This simplicity also comes with a lot of It's very generic. Like you send byte arrays, you get byte arrays, basically. That's the kind of things. And the response is structured in some way, but yeah, that's it. So I'm going to start a very, very short demo to show you how it looks like. Can you switch to the... Yes, perfect. Okay, so the first thing, I already did it, but I created a project with the Redis clients, and the rest is the reactive JSON. So if you were using the Redis client, it's the same extensions, just an additional API that you can use. So, but the previous one is still there. All right, and now let's go to my IDE here. So the first thing I'm going to do to demonstrate the simplicity and the low-level API first, before we go to the new API, it's I injected a Redis object, which is provided by Quarkus. It's actually provided by Vertex, but it's exposed as a bean in the Quarkus platform. And here I'm going to just I'm going to start by saying I want to store var to some key. So I will create a command. Send request command. And here, as you can see, there is plenty of commands. So you need to know a little bit the one you want. So here it's set, okay. And then I want to pass my key A, for example, and then the value. So how do you know that structure here? Well, you will have to go back here to the Redis command list, go to find the set command. Oh, which one? Because there is plenty. Yes, this one. And here you have the syntax, and you will have to write that syntax. So it works, very simple, but sometimes it feels a little bit weird to have to do that. So let's go back here, and I will return that. But yeah, that's return a response, and I don't care about the response. I just want this. Here, same thing. I want to do return redis.send request. Oops, no. Request.command. So this time it's get. Okay. I want to pass my key because that's a format. I want to pass my and that's it. So here I get a response back, as I said, command response, except that this response can be null if there is nothing stored at that key here. In that case, I will return null. Okay. Else, I want to pass it as a string because I know it's going to be a string. Let's simplify for now. So now I have this. I will go back to my terminal here, and I'm going to start my Quarkus. So as for most of our data source and things like that, we provide dev service for Redis, so you don't have to do anything, just there for you. And now I just need to remember this. Yes, so that's low. Okay, so let's try this. No. Yes, it's a Q4. Yeah. Okay, now I'm going to pass something. Yeah, for example, a value. Okay, and now if I go back here, I get the value stored there. So it's working. So that's great. My first things with Redis. But yeah, you have to read the commands, you have to know the syntax. It can be a little bit weird and a little bit too low level for most people. However, this API is available, so you can use it. If you really want to go low level, if you want to emit commands that we don't provide support yet, you have that way, and you can do that. But you will need to know the commands and things like that. In addition, here I've just returned a string, which is fine. Redis provide a lot of different data structures. So we have plain value, like this string, which are named Redis strings. And that's very, very confusing because a Redis strings is not a Java strings. A Redis strings can be a Java strings, an integer, byte arrays, binary, whatever. So it can be huge, actually. So there is a bit of a mismatch here with what we do in Java. It can be a list, we will see that. It can be a set, it can be a sorted list, it can be a probabilistic data structure such as a hyperlog, Bloom filter, or QCO filters, or top K list, and so on. So we have plenty of things. If you extend that to the Redis stack, I'm going to talk about that at the end of this insight. You can also have graph or JSON documents, or even full text search. All are different data structures you can manipulate with Redis. So the simplicity and the command set that Redis has, as you can see, it's a lot of commands. Yep, we go back here. Make it very well a great platform. So, for example, you need to compute a leaderboard. We will see that later. Then you will just use a sorted set, where you have a dedicated set of commands to handle sorted set. Or you want to do a Bloom filter, then you have a dedicated set of commands to manipulate Bloom filter, and you can do a lot of things like that. So we will see that. So we can have hash, for example, very convenient for session store, or you can just use the plain strings for and the get and set method, because sets come with a setx. With an expiration, so you can try to cache very easily. You have stream support if you want kind of Kafka without really being Kafka. We don't support stream yet, but that's something I need to add. So there is plenty of things. PubSub if you want messaging. So you have really a lot of commands to do a lot of things. As you can see, these commands are grouped. And these groups are actually very important, because if I give you this, it's way harder to understand what you need. Like just when we look for set, we had hset, set for hash, HM set, multi-set for hash, we had a set NX, we had JSON set, we have reset.
Too many sets.
L set,
set exception.
Set. So there is a lot of sets, and imagine get at even more. So it's not really navigable, and having all those commands listed, yeah, that's not great. So one of the things we wanted with this new API is to have groups, like we did in Mutiny, more or less.
Yeah,
so,
that was what I was gonna say.
Yeah,
Take a page from Mutiny's playbook.
Exactly. So we want to have groups of commands dedicated to a single data structure you will handle. We want them to be type safe. Passing strings back and forth, great. But who is doing everything with strings? Sometimes we need people, sometimes we need superheroes, sometimes we need recipes, sometimes we need Quarkus team members, or whatever. So we need higher, richer entities, more than just strings, especially because Redis strings can be byte arrays and things like that. Obviously, we want reactive and imperative. Everything I will show today, actually, I believe, is imperative, which is kind of surprising for me. So I'm trying to learn the other way. But everything I did obviously works in reactive, which would have been so much simpler for me. But anyway, it will handle all the marshallization, it supports transaction, and so on. But that doesn't answer the question: is why do we have a new API? Well, Redis is very popular in plenty of use case: cache, session store, job queue, PubSub, geospatial database, and so on. And our previous API didn't support all the commands. Was very generic, which made for a Java regular developer or Redis newcomers a hard step to try to understand or try to use it. So we wanted to really improve that. We don't want to denature Redis, so it's still commands. You still need to know these commands, but we are going to try to guide you to tell you, hey, that's the kind of data structures. Here are the commands that are available, which is a lot less than what you have if you look at all the methods. So let's start with the first demo for our API. How does that work? So I'm going to redevelop exactly the same application as before, but with our new Redis data source. So I'm injecting it, provided by Quarkus, nothing to do. And then I want to manipulate values of type string, and that's it. There you go. So on the data source, you have all the groups you can imagine: a key set, sorted set, bitmap, hyperlog if you want to look smart in society, and things like that. And you just say what type you want to store, and you're good. So now,
Love it.
I
have a question, actually.
Yes.
Are there any other clients that do this? Because this is like, this makes things so much easier, right?
No, the other clients tend to love having very huge interface with hundreds of methods, which cause problem because you have groups that are not available for your Redis. So you have no way to filter that out because, typically Bloom require Redis, the Redis lab stack and things like that. So here the group will just say, well, if you don't have it, it won't work.
Excellent.
So, and if you go to values, you only have the commands. This one has a lot of commands. Some have less commands. But you have the commands for manipulating your things. So you have get and set, psetx, dec, because as I said, it's a Redis string, and so on, and nothing else. So you're good for that. So if I now go there, so it's like yes. And if I go yes, that will return a 2 or 4. If I do...
Actually, we have a question from Max.
I don't see the chat at all because I have a 504 is useful, sorry.
Right, I brought it up on the screen. I think you already answered this, but let's reiterate. Will both old and new style API be available?
Yes, the old API is still there. It's deprecated, but still there. It will stay there for at least 6 months. So you have time to migrate. I still on the roadmap. I need to write a document explaining how to migrate. So you have the choices between going to the low-level API that I showed initially, which is closer to what we had initially in Quarkus, or to the new API, which is closer to Panache and repositories and things like that. So you decide, but both
maybe
would.
We could also have like some what's it called, an open rewrite rules or something like that to rewrite things.
Yeah, that can be something. Yeah, definitely.
From what version is this available? From what?
212 something. It's already available. If that's the question, yes. But was that 211 or 212? I don't know. Things happen, release are cut, and I'm behind. That's all. So does that work? Yeah, it works. So it is. I have exactly the same code with just Redis data source. I know that I can pass string. Here, I cannot pass anything data string. If I pass 12 here, it doesn't compile. We have all the type safety that comes with it. So, as I said before, the first things we will do when you use Redis, I ask a few users and say, well, we use Redis for a cache. So how will you implement a cache with this new API? And we are not going to cache anything. We have one great business model at Quarkus. We want to cache superheroes and supervillains. So I'm going to have the same thing, value commands, where my key will be a string, but what I'm going to store is superheroes, what I call soups. The soups is a record, Java 17, name, level, pictures, whatever. Nothing very smart. How they're retrieved and so on. The code will be available, is already available actually. So there is nothing, it's just where are they? Just an import file in JSON, so nothing very interesting here. So the thing is, where is my? Yeah, here. I want to get superheroes, okay, and I want to simulate a fight. That's always what we do. So we take two superheroes, we simulate a fight. but a fight between superheroes takes time. It's not something you want to do every time. Remember, well, Georgios and Oli probably know, but when we were young, we watched Dragon Ball, where one fight could take one season.
Oh,
So
I
50
remember that.
episodes, yeah. It was so
That
long.
was crazy.
So you don't want to redo it, to restart from scratch, or you want to have some time for that, because well, let's say that.
Very good idea.
Yeah, so I'm going to try to do this. So what I have here is I have this cache resource here, which has a fight method here, which receive a fight request, which contains the ideas of the two superheroes I want them to fight. Okay, and initially, in my first version of my application, I just get the first superheroes, the second superheroes, and do the fight, which takes some time. Okay. So now I want to avoid that, and if I ask for the same fight between the same superheroes, well, I will pick it from cache instead of recomputing. So to do that, the first thing I need to do here is to say, well, is it in the cache? So I compute a key, which is cache dash my first and second fighters. Okay. And if subs is not null, that means that I already did that fight, and I know who is the winner. It's that subs that won that fight between these two superheroes, so I can return that subs. That's it. So the winner will be that one. Okay, now where it's a little bit more interesting is instead of doing so I'm computing the winner, but instead of returning it immediately, I'm going to cache it. Setx. Okay. Let's do it in second. Okay. So my key will be the same, and I want to keep it for 10 seconds, something like that, and the winner is winner. So now if I go back here, I need to remember. Yeah, so for example, this one. So if I have a fight between these two superheroes, so 3 and 24, it's taking time, you see? Yeah. And Red Hood won. I have no idea who is Red Hood, but let's have a look. Who is Red Hood? That's Red Hood. Ah, nice. But if I go back here quickly, then I wait for more than now it's immediate because it's cached. And if I ask for another one, like the 25 against the 3, so again slow, but if I do it immediately because I cache it for 10 seconds, so it's cached, and if I wait for 10 seconds, no, we'll do it. Oops. Yeah. Cache has been invalidated, so I will compute it, and so on. So here is how you do a cache in very few lines of code. You don't have to handle the marginalization. Timers are passed like this, so relatively easy. You have the version with P. P, the only difference is that the time are given in milliseconds instead of seconds, but for a cache, it's very rare when you want to be at the milliseconds for a cache, because there's probably use case, but not for this.
So how is serialization, deserialization handled here? Because you're just like setting the winner, right?
Yeah. So at the moment, it uses Jackson. To be, it's something I want to make pluggable, but for the moment, it uses JSON. So the subs are written into JSON and so on. So the advantage of that is that it's easy to read and to understand what's happened, because it's almost human readable, but we want to extend that with more advanced serialization. Typically, I have a prototype using protobuf. The only issue with protobuf is that you need the schema first and things like that. So yeah, it's a little bit more less convenient, but yeah. Here, JSON is It's also something I ask is, what are you using? And most of people say, well, we are using JSON, so it's good. It's a good thing to just use JSON, at least for the first,
Right.
the first things. But yeah, that's something that will be pluggable later.
I've used Redis a fair bit from JavaScript, and I've never used it from Java, so I've never sort of seen the Java API. But when I was using it because I was using it on the front end in Java, and it sort of then fixes some of the problems that you get with state when you have your application spread across multiple instances. But I have a feeling that I never even knew there were more API methods than get and set. Do we have a sense of like how many people go past the get and set to those more sophisticated methods? And would it have made sense to do just sort of the golden path 80% API that just had get set?
It's a great question, and actually, for years I was thinking that Redis only had get and set. So, why? Well, if it's just a map, oh, fine. But actually, there is plenty of other things, and let me answer your question by doing the next demo, which is a session store, and my session store is a shopping basket. So you start doing your shopping errands on your phone, blah blah blah, because you're on the plane or on the train. You do things, and everything is fine. But then you want to continue from your laptop or something like that, and it's lost, and that make me angry, like impossible. Like you have to restart everything. So a session service can let you do that, so keeping the session open and remembering things. But for doing this, you need to go beyond get and set. So typically what I did here is that I used hashes. So a hash is a map. So basically my key is now not only going to be associated with a single object, but with a map, which I would have key values. Well, to make things confusing or less confusing, I have my keys that will target field values, and so on. So it's very nice if you want to manipulate objects, which are fields and things like that, because you can manipulate a single field. You don't have to resend everything. If I want to send a single part of my hash, you can. You have even method like give me a random field, which is always tricky. Like, okay, fine, there is few things like that can be very, very interesting. So for doing this, I have a hash command, which my key is a string, my field is a string, but my value is an integer because it's a shopping basket. So this is going to be the product name, and this is going the quantity, like how much stuff you want. And I will for this demo, I'm not going to use one group, but two groups. I'm going to use the hash group to store integer, okay, that one. And I also want the key group that can add expiration to any key. So you can take any key, even if you didn't do a set X, but any key, even a hash can have an expiration or something like that. So it's very, very useful in that case. So if I do a set, so this is my user ID, this is a product I want, this is a quantity I want, I will just do hset session field value. That's it. And then I need to extend the expiration saying, well, I want to, because it's a session store, every time I do a touch, I want to extend the expiration, so I just extend by timeout. If I do a get, I'll just do a edge get session field, and I will get my my value. So now if I where's that? So and my shopping basket service is just using this. So this is the name of my session, which can be username or randomly generated and so on. And yeah, that's it. So if I now go there, I need to check the API. Forget about that. Yeah. So if we do session, so Clement doesn't did anything. And now if I do this and I want 2 coffee, okay, and if I go back here, I have 2 coffee, and if I want, for example, here, okay, now I have my shopping list. If I want to do another shopping list for Oli, which is empty by default, and Oli want wine. Now, if I ask for Oli, so the shopping basket has that. And if we wait, I can't remember how long it got. Where is that? 60 seconds. So we're not going to wait, or maybe mine is now has not expired. No, it's still there. But you can build a session store like that. Again, I just use 2 groups, hash to store my shopping cart, and key to set the expiration of my session if I want to do that. Of course, you can at any time decide to remove the session from the store, which is what we do with the remove method I have here, where I just delete the session ID of the product, or delete completely the session from Redis. So you can do that too. And you see, you can go beyond simple get and set. Here we are using another data structures, which is better for that kind of shopping basket kind of things. That being said, it's probably not enough to convince you to do just because you can do that with get and set. Basically, you will have to send it every time, everything, but okay, fine. So let's now go back to our business model, soups. So
I'm assuming that you're gonna do the leaderboard use case or something.
Yeah, I'm going to go a little bit in this direction, but first I'm going to implement a job queue because simulation requires specific hardware, which in my case will all run in the same process. But but imagine that you want that, and I want 2 simulators. So again, I have 2 soups. I simulate the fights, and I have 2 simulators. One which is named A, and the second one which is named B. 2 threads. They can be in a distributed environment. You don't care. They're just there. So what we are going to do is to say every time I have a fight request, I'm going to submit a fight request into a job queue, and my simulators will pull that job queue, get the request, do their thing, simulate the fight, and send me a result using PubSub. So to do that, I cannot really use get and set. That's really where we see the limit of that. You need a queue, which in Redis will be from the command group lists, where I will write my request. I'll push. So at the left side of the list, because you can do on the right side of the list too, but here I'm going to be on the left side of the list. And I don't remember the name up yet, so that's fight results. Just that's probably fight. Well, let's try fight request. So that's my key, and I want to send my request or write my request to my list. That's it. And then I do this, and the rest would be all asynchronous. On the other side, in the simulator, so that was my name. Let me sure I wrote it. Yeah, because use constants. Don't do like me. So now I need to write my polling, but I don't want to do a constant polling, because if you do constant polling and you have no requests, then you will just burn CPU for nothing. So we want something a little bit more fancy, and here I'm using another command, which is brpop. So let's do that. That's q.brpop requests, and you pass a duration. So that one is a little bit different. It's duration. Okay. items. So okay, yes. Here pop is a blocking write pop. So it's going to go to execute command here. So basically, it's going to pop the value which is on the right. So we enqueue on the left, we read from the right. But the B is important. It means blocking, not blocking in the reactive sense of blocking. Blocking because we want to wait for 1 second until we just give up and say, well, we don't have anything. So that avoids the CPU being burned. That's it. And now, now I need to send my results to using pubsub. So to do this, I have another group, which is the pubsub command, and I will just do publisher.publish fight response. Let's see what I had. Fight results. And that's my result. So pubsub is a really pubsub communication. So you send to channels, which actually is a key, and you read from that channels, and that's what will be read from here. In that example, you see that I'm also using the reactive Redis data source because, well, sometimes for me it's really way more easier to switch to the reactive things, especially when we deal with events. But it's up to you. We also have the asynchronous API, the imperative API. What's important here is that you have the choice. You can combine both. There is no problem doing that. So now if I go back here,
very nice,
and I go to this one here, and I call fight many times, you will see, and that's the queue. So the queue gets processed. So that's why it's completely asynchronous. It's not slow. It's just how it works. And don't look at the leaderboard yet. We are going to talk about that later. But basically, every time I do that, it's right in the queue, and then I have my simulator that dispatch the work. Because Redis BR-pop is atomic, you can be sure that no fight request will be processed twice by the queue simulator. This is not the perfect implementation of a job queue. I'm going to write a blog post explaining how we can improve with avoiding ahead of line, improving resilience, and things like that. So, well, Georgios already saw the second part of the code, but yeah, basically you need to go 1 mile further if you want to really build something solid. But yeah.
Cool. Oh, sorry. Go ahead.
You see, someone's going to ask a serious question, and I'm going to ask if Redis is Turing complete.
I doubt it.
It's a lot closer than I realized.
It
sure is better than what we thought. Like it was like memcache + or something.
Yeah, it's a lot more than this. Now there is plenty of things that are not possible. But seriously, when I started this journey, I didn't know Redis, and I say, well, come on, that should take me 1 week. Get and set that pattern. Get and set and done, and delete and CRUD operation, and that's it. And I started that in April. We are in October. I'm still not done because it's very rich. And the fact that you can use the same piece of structure for all these cases sometimes doesn't make sense, but sometimes instead of having to reinvest in something, if you have Redis in place, maybe it makes sense to just use it right. So yes, of course, you can do a job queue with Artemis or ActiveMQ or IBNMQ or RabbitMQ or whatever. But if you already have Redis in place and you don't need super fancy features, it works.
Actually, that's something I've heard a lot lately, right? Because I heard the same argument for people using the like job queue features Postgres has, right? They're like, I already have Postgres and it works wonderfully. Why don't I just use that? And in that case, you also have like transaction support, right? So that's pretty interesting, I would say, especially like when teams are supposed to like run multiple
Exactly.
Yeah.
Less piece of
system.
infrastructure, you need to
Yeah, exactly.
monitor, observe, SRE, and stuff like that. Better it is. If you have good
Yes.
experience with Redis, use it.
Yeah. Because normally we'd say like, oh, if all you have is a hammer, then everything looks like a nail, and
Yeah.
we'd be like, oh, you're so silly for not using the right tool for the job. But hammer maintenance adds to the cost and the cognitive workload of
Absolutely. Yeah.
your team.
Yeah, any broker is at least 3 instances because of the CRM. So you need 3 instances of Artemis or anything. Yeah, but if you already have 3 instances of Redis, well, why? So again, it's nothing against Artemis or just if you have Redis and if the feature set works for you, that can be a possibility.
Very cool.
So now the
Okay,
leaderboard, because
well, before we do
yeah.
that, we have a question actually from
Yes.
from our viewers. The question reads: Redis is also a multi-model database. Does this library offer, I guess, other model serialization, JSON and graph query, for example?
So JSON and Graph are both part of the Redis stack. JSON has been added 2 weeks ago, so you can use JSON document and do all the JSON commands, which are pretty cool. Let me show you that because I was amazed by this.
I never knew this.
So
it has JSON support. Wow.
Yeah, and actually you can do you can write. Why is that? You can write a JSON pass. So
Wow.
you can actually query huge document using JSON pass, and that will return exactly what you want. And it reminded me when I was using Berkeley XML database. Yes, that was a very, very long time ago. But when I was using XSLT and XPath to do my query, I found the same experience, and I really liked implementing that part because I was like, wow, that's so cool. I can do plenty of things that I didn't know. Graph is a very interesting beast. Graph, the pull request has been opened yesterday evening, and it's been validated this morning, so probably next release, I will say. The thing is, Graph took me a bit more time because I had to think. Graph, you pass such kind of objects here. So basically what they call the cipher language.
Wow.
Yeah, and it's pretty flexible, like SQL, if you will. So I needed to find a way to map, especially the return clause, to things that make sense in Java, because you can do a lot of things. So sometimes you don't have a return. Sometimes you can do operations such as let me show you one example. Is there no count? Yeah, count or collect or things like that. So it was a lot richer than what I anticipated, but we added it. So next release, we'll add it. It's that one graph is marked as experimental because of this mapping that may not be complete. So if you have that use case, please try and give me feedback. Maybe it's okay. Maybe I'm missing a few things. So yeah, it's pretty hard because again, I didn't know they were able to do that. So
Wow,
I was thinking, when I was thinking graph database Java, I was saying, well, Neo4j, and actually, Redis does it.
Very cool.
So, any other question, or do I switch to the leaderboard?
Yeah, let's go to the leaderboard.
So the leaderboard, very simple. I want to know how many, which cubes won most of my fights, and for this, I need something a little bit different, because of course I can keep track of all the things and count and things like that, but that's all in memory, and I don't want to do that because, as Holly said, we might be in a multi-pod or multi-instances of my app, and I want to have the same state everywhere. So for this, I'm going to use a sorted set, which is one of the data structures of Redis, which will keep things automatically sorted. So you don't have to do anything. It just keeps things for you. So basically what I do is that every time I get a fight results, I'm going to increase to add an item or increase an item in my sorted set. So my key is leaderboard. I want to increase the score by 1, saying I won 1 fight, 2 fights, 3 fights, and so on. for the winner. So basically, you can see that the list of pair winner score that will be always sorted by highest or lowest score, because that's one of the cool things. You decide which sort you want. So, and typically here, I'm going to do a Z range with score. Give me the top 10, which obviously in Java expressed between 0 and 9, which is always crazy, but yeah. And because I want the highest first, I will just say, well, I want a reverse order. Actually, I was pretty sure. There is no range? Oh, okay. I was thinking there were a command where you can just say ref. You can say that range is pretty rich because you can have with score or by lex, by score, or anything. So we can really change how you want to sort things. So it always keeps things great. And yeah, and I will just send the results to my UI, which is what we see here. So Green Arrow 1, 2, Batman 2, Lucio 1, Lois Lane 1. Okay, so let's do a few more fights. Again, that's still the same thing. So we have the queue and the simulators that continue doing things. So Batman 1, 3, yeah, that's a Batman day today. Madame Hydra 2, Xavier 2, and so on. So, and you see it always keeps things up to date. So any of my nodes, it would be fine. So, and why sometimes it's faster and so on, it's because of the nap time of a fight, because there is some random inside. So, Green Arrow is 4 now, so that's kind of cool too. Yeah. So now to handle a leaderboard, you can do plenty of things. You can do SQL query in regular database or things like that, or you can just ask Redis to keep things. So all your instances will have the up-to-date leaderboard, because every time you increment, it's increment for everyone, and so on. So that's I found that pretty cool. Oh, we got Casca versus Casca. So that's the beauty of random. Like, yeah, sometimes bad things happen. A few more. I can't remember. I think I have 50 soups in the database, something like this. Anyway, this UI is this application is very addictive, so I need to go next. The next things, and that's also something I didn't know, geospatial. You can use Redis to handle your geospatial data. So here what we have is some people from the Quarkus team with where they're living. Well, estimates, because yeah, I didn't answer exactly.
You're gonna dox us.
Yeah. So, but basically, I just say, well, I want to have to store them, and here, because I'm doing two things at the same time, want to introduce my geolocalization, but also the list, the list of the member. I want to do that in an atomic transaction, so that's why I do ds.with transaction. I retrieve my Redis data source, I just do data source with transaction, and this will run in a transaction. So if there is any failure, it's rollback. I can even do something like, I want to monitor member list key and member pros key, which means that if I have any modification from anywhere on these two keys, the transaction is rolled back automatically. So even if I don't fail, if at the end I realize that something changed in these keys, they say, we roll back. So, but here we don't need that. So I introduce my things here, and then I have Geo service, which answer one very important question. We always ask, who is the Quarkus team member the closest to my place? Really, Georgios, I know that was a question you were wondering. So I have the answer for you. Let's go back here and go back here.
Let's see.
So that's basically where we are. So we have Georgios here. That's a G. We have Oli, which is around. Oh no, I don't have Oli. So Oli, you won't know, but I know you're living around this. So let's say that. So for example, if I ask for Sunny, so Ozan is at 43 kilometers from Sané. Dimitri is at 686 kilometers from Sané. And Julien, 600, Julien Ponge, 694. Guillaume and so on, and me, 700. If we ask for Georgios,
Yeah, I'm far away from everybody.
yeah, Stefan is 1,517 kilometers from you. This is direct line, so
exactly.
It's not a Google travel estimates, so it's probably going to take you 2 days to do that. So Andy's and Dimitri's, me and Guillaume. If I ask, I don't know, Max. Max. Ozan is the closest to Max. So, and then we have Sané and Dimitri's and so on. So Dimitri's is actually very well located because he's kind of close to everyone. So it's
in the center.
Smart manager, you see?
Excellent management.
Yeah, that's pretty interesting. And I did that again, geospatial, a list of geospatial entity, and then I just said in my code, I want to do a geo search where I want in a box of 5,000 kilometers, I want to run them from the closest to the furthest. I want only 6 of them and around me or around a member. So you will pick the position of the member, draw a box, find the closest, and do that. Why 6? Nice. Because the closest member to a member is itself. Yeah, that's why you have this. Keep the first member here. This is not me. This is the Redis API which does that. So yeah. So the closest member of you, Oli, is you. So that's not very useful, but just in case you forget, yeah, Redis provides that answer.
Thanks, Redis. But we need to do the extension to this now, because we were talking about how our productivity is so closely correlated to how much time we spend on trains and planes. And so that, I think, really, we've just got the explanation for why Georgios is the most productive of us, is because he's furthest away.
So we can combine that with the Graph API from Redis to have the shortest track and things like that. But I want to end with one last demos. And you may have heard a few weeks ago, Java 19 has been released. And one of the core feature or cool feature of Java 19 is virtual threads, aka Project Loom. In Quarkus, we have an integration of Loom since April, something like that. So quite a few months now. But we still have plenty of things we want to work on. But when I designed that Redis client, I said, well, we need to be Loom friendly. So what I have here is exactly the code I had before. The fight things with the cache and things like that. So that's the code I did, except that I run on virtual thread.
Awesome.
That's my imperative code. Same code. The only thing I said, run on virtual thread. And now everything will run on a virtual thread. We will see it's going to work. Go back here. The first one takes time because it's a fight between 3 and 23. And it's Redwood 1 again. And now it's fast. But what's interesting is it's run on a virtual thread. And you don't have to do anything. So that Redis API is completely compliant or friendly with Loom. No pinning, no monopolization. You're safe to use for the next decade. So
sweet.
That's more or less all I have. I wanted to talk about Redis Labs, but I already mentioned it. All the probabilistic data structures, so Bloom, Kuko, TopK, can't remember the other ones. They're pretty smart, but they are provided. However, you need to have the Redis stack on your server because that's, the server needs the commands. JSON has been implemented. Graph is coming. Search is next. Maybe this week or next week will depend on the amount of unplanned work I have to do, which seems to be a lot again this week. So might be postponed to next week. I know search is something people want, and I hear you. No problem.
So just search is like a full text search thing?
Yes, full text search.
So Redis does everything, basically.
It does a lot. Essentially, it does a lot. Search is there. So, oops. Yeah, I want to through that. So
Cool.
you can get a list. You can add things to dictionaries, and so it's pretty nice. But I need to learn how to use it. I need to do the mapping, and I need to implement it. So that's why it takes a few iterations to achieve this. But yeah, it's pretty cool. After that, after search, I would have auto suggest, which is missing, and time series, because obviously it does time series. So yeah, that's the next few. TDJust is kind of weird because it's documented but not provided yet. So don't try to use that. I actually have the API, but well, it doesn't work because there is no server providing it yet. It's coming.
Is there any machine learning here? I mean, it does everything else.
No, not yet. I think that's a missing one, right? Something like
exactly.
but it's so. I was like, holy, like, well, it's probably simple, just a cache plus, and I was wrong, and I actually really enjoy the simplicity of it. Command request. Well, I on my side have a lot of boilerplate because I need to do the args, pass the right arguments, decode the response, and things like that. But pretty cool. On the roadmap, we have, in addition to these groups, we also want to improve observability and metrics. Something I have discussion to know what kind of metrics we want, and things like that. So that's more or less it. Health checks are already integrated. As I said, the dev service is there, so ready to be used.
Oh, this is so cool. Yeah.
And remember, you can already use Loom. There is no problem with that API. So use REST Directive, Redis. You have your stack for the next decade.
Probably more.
Yeah, probably more. Sorry, that's all I have.
Awesome. We're at the top of the hour anyway, so I
Perfect.
think you timed it perfectly. Yeah.
Perfect.
So, Holly, do you have any last questions or remarks or anything?
No, I'm just trying to absorb all of the new knowledge.
Yeah,
this is excellent. Great stuff. So we'll definitely keep Redis in mind for next time we need anything.
Which is kind of the scary thing. I need anything. I'm going to use Redis because it's probably have a group of commands to do it. Actually, they probably have. So it's.
And now we have an awesome API that works everywhere.
And you can, if you really feel like it, you can also implement your own command on the server side. And I didn't show that, but basically you can also execute any custom command. For example, yes.execute. You just pass the command name, the arguments, and boom, you're done. So that will return just onto the string. So you probably will have to decode it, but you have it. So if you need that, you can also do this.
So what do you write it in Lua or something on the server or something like that?
I don't know. The client side already make my brain go there. So with plenty of cool ideas and things like that, I think, well, wait a little bit before you start looking at all your vacations and PTOs are going to disappear because crazy ideas. As you see, it works with records and things like that. So it's very simple, very modern at the same time. If you already have Redis, it's more than just get and set.
Amazing stuff. Great. Thanks a lot.
Thank you for having me, and I hope you like it. Something I forgot. Maybe you can just pause that really quickly. All the code I've shown is available on that URL. Let me show that here so you can share it.
Yes.
All the demos. So exactly what I've shown you. ABCD because I need things ordered. So it can be meaningful or ordered. Well, ordered. Basically you have everything. The Loom demo, for example, is probably the last one, and so on. So you have everything already. So use it.
Great, thanks a lot.
Cool.
So we'll see everybody next week, I guess. So have a good day, everybody. Thanks a lot.
Bye, everyone.
See you up.
Bye.